Hello and welcome. This is sets video number 18 and today we are learning intersection of sets. Now we know that in this grade in class 11 we are actually learning about these operations of sets. Union of sets, we have already studied this in video number 16 and today we are learning intersection of sets, and next we will handle difference of sets. So let's take a look at what is meant by intersection of sets. Intersection of sets is defined as follows. Say we have two sets A and B. The intersection of set A and B is going to be a set that contains all elements that are common to both A and B. So let's take an example. So let's say we write our set A as A contains number 1, number 2 and number 3. These are three elements in our set A. Now let's also arbitrarily write a set B that contains, let's say, element 2, 3, 4 and 5. So what is meant by A intersection B? Well, first find out what is the symbol we use for intersection. We know that when we add two numbers, we say 2 plus 3. So this symbol is for addition. Similarly, when we subtract, we use this symbol to represent A minus B. So here, what is the symbol for A intersection B? The symbol is this. It is a upside down U, shaped like upside down U. So this is symbol for A intersection B. So now let's find out. So what is A intersection B? Well, we know it is a set. So this will be a set. We open and close curly braces like brackets like this. Now a set contains elements. So what elements go here? We are looking for elements that are common. Elements that are common to both A and B. So let's start with each element of A and see if they are also present in B. 1 belongs to A, but 1 does not belong to B. So we cannot write 1 here. 2 belongs to A, and we see that 2 actually belongs to set B as well. So we write the number 2 as one element here. We similarly notice that number 3 belongs to both A and B. So we write 3 here. There are no other elements which are common to A and B. So A intersection B is this set that contains 2 and 3. Now let's take a look at one more example. Let's say this time our set A looks like this. Let's write the same set, so 1, 2 and 3. But for set B, let's change this up a little bit. Let's say the set B contains 10, 20, 30 and 40. So this is A, this is B. So how are we going to find A intersection B? Well, we are going to start with every single element of A and we will check if they are also present in B. So let's open a curly bracket like this. 1 belongs to A, 1 does not belong to B, so we cannot write 1 here. 2 similarly is not present in B, 3 is not present in B. So it looks like this actually has no elements which are common to A and B, or this is actually a null set. So when we have a situation where A and B, they don't have any common elements, we call these two sets disjoint sets. So you will come across this term sometimes, disjoint sets. So disjoint sets, in this case we say set A and B are disjoint sets. It simply means that A and B have no common elements. So A intersection B is a null set. Now let's find out how do we represent them in Venn diagram. We have studied Venn diagram before, and I'm going to provide the link in top right corner of this video as well for what is a Venn diagram. So the first example, actually this is more the second example. So let's say this is our set A and this is our set B. So A contains 1, 2 and 3 and B contains 10, 20, 30 and 40, and this is a universal set U. So in this case, A intersection B will be represented like this. So this is our set A, this is B, and this is U. I'm not writing the elements again, but point here is that A intersection B is basically null set. There is no part of A and B that overlap. They don't have any common elements. So let's do a contrast with the first example. So in the first example here, so this is the second example and this is the first example. So here we had set A and we had set B, and A contained the number 1, number 2 and number 3. I wrote number 2 and 3 here in a part where both A and B, they overlap, because 2 and 3, these elements are common to A, set A and set B. So we had 2, 3 and I believe 4 and 5. This is the universal set. So in this case, A intersection B is represented by pink color part or the pink colored portion. So here this is A, this is B, and A intersection B is the part which is common to both A and B. So here this is element 2 and 3. So this is 1 over here and 4 and 5 they are here. But the part which is common to both A and B, A intersection B, as highlighted by this pink colored portion, this is 2 and 3. Now let's quickly take a look at some properties of intersection of sets. So A intersection B is the same as B intersection A. This is known as commutative law. Now this is quite evident if we simply look at the example here. When we say A intersection B, now in this case we get this common part colored in pink. And if you were to do B intersection A, we will again get the colored pink colored portion. So A intersection B is same as B intersection A. And in this case, when we have disjoint sets, A intersection B is a null set and B intersection A is still a null set. So A intersection B is indeed equal to B intersection A. So similarly, we can visualize if we do A intersection B, and if the sets are not disjoint sets, so we will get some common part. And if we do that intersection C, then we will get a set that contains elements which are common to A, B and C. So similarly here on the right side, if we do B intersection C, it will give us elements common to B and C. And if we take that set and do an intersection with A, we are going to get a set that contains elements which are common to A, B and C. So these two will be equal. This is known as associative law. Similarly, A intersection a null set will be equal to null set. This is known as law of phi. Let's move on. A intersection A is A. This is idempotent or idempotent law. It is very intuitive because if you think of A as a set, A contains 1 and 2, let's say. And if we do A intersection A, we are trying to find out elements which are common to both this set and this set. So we will find element 1 and 2 which are common to both sets, but 1 and 2 is nothing but set A. So A intersection A is equal to A. And the last property that we are going to focus on is this. U, which is the universal set intersection A, is going to be the set A. So here let's draw this quickly. So let's say we draw a rectangle here representing the universal set. So this is our universal set. And let's draw a set A here represented by this circle, let's say. So U is this universal set out, the entire universal set, and A is this circle represented by the circle. So when we say U intersection A, we are trying to find out all elements which are common to U and A. And we see that all the elements that belong here, they are common to both the set A and the universal set. So we say that U intersection A will be equal to the set A. So If you are enjoying these videos and if you want to watch more videos, please subscribe to the channel so that you are immediately notified when I upload new videos. Also, please check out the new website risingpearl.com, where we are putting in new problem sets almost every day for you to practice on various concepts that you're learning here.